All right, so I just saved this. I did a file save as so that we can continue to save this. I did a little bit of notes here, but we're first going to start with establishing those variables for those pins that are used. That's the AO, the 5 volt, the ground, and a 9. So literally, we only have to establish for 2 pins. We have some variables for those 2 pins. We're going to start with integer, and we're going to go to that pot pin. So that's the potentiometer pin, and that's A0. And then we can close that. And then all we're doing here is we're saying, hey, we want to have an integer. We're going to call that integer a name and set it equal to something. We're going to do the same thing here. We're going to call this LED pin. And we're going to set that equal to pin 9. And we're going to close that. And so what that's doing is this one is setting that pin to the potentiometer pin of the middle leg to A0. And then this one is setting that pin 9 and calling it LED pin. That's all it is. We're setting it to a PWM capable pin for pulse width modulation. And then we need to set 2 more variables. One, again, to store the data coming in from the potentiometer sensor. And in this, we're actually going to dim and make bright the LED. So we're going to have that door to that variable to store data and manipulate, right? And so we'll start with storing the data in sensor. And we'll call that, we'll just set that equal to 0 to start with. And then we're going to go another one, and we're going to call it brightness. Say brightness, and we're going to say that set that equal also to 0. And then, so this one is just for a variable to store the knob data, the potentiometer data, and that data was from 0 to 1023. And then we need another variable to map and store analog data to digital data, and that's brightness. We still, like before, we have that one setup code that runs once, and we still need to set up our pins there, our serials and all that. So in this case, we only need to set up one digital pin. These analog pins are already set up. They're already ready to go for voltages, for taking in sensor data. So we don't really need to mess with that. It'd be redundant if we said and did this like the pin mode we normally do. So we only really need to do those for digital pins. So pin mode, like before, and we need to do pin 9, but in this case we labeled it. We called that pin LED, and then we're going to send data out to that pin. So we need to say, hey, output again, and then we need to close that line. And essentially that's all we need to do right here is just say, hey, pin 9, we're going to send data to you, LED pin, right? And so we can move on and go to our main code. And in this, we have to take in that sensor data like we did before, from the potentiometer data, and we're call that sensor, and we're say, hey, sensor analog read. What we call that? Pot pin. Analog read pot pin in. And so all this is saying is, hey, read in the analog data and store that in sensor. That's all it's saying is read in the analog data from A0 and store that in sensor. We can kind of add some comments here so you can end up seeing what we got here. But right there, we're going to tell the Arduino pin 9 will send data to you, and then we're going to read in that pot pin data and store it in sensor. All right, and so then the next line, we have brightness, and we're going to use this new mapping thing. We need to map from this 5 volts, which is 0 to 100 or 1023, and we need to map that onto a digital signal. We need to map that onto 0 to 255 for the PWM, right? And so that calls out this new function we call map. As you can see right here, map, long, right? And in this first one, we're going to say taking this data from this sensor, let's say sensor right here, taking the data from the sensor, and that data, we want to map that from this range to that 1023, and we're going to map that onto PWM, which is 0 to 255. And so we can go 0 to 255. And then store that in brightness. We're storing that in brightness. We're saying, hey, map sensor 0 to 223 and map it to 0 to 255. That's all you're doing with this. And then store it in brightness. Remember, we got to close that. And then it's essentially just a conversion or mapping onto that, like just converting this range down to this little tiny range, right? And that's all it's doing. So we then can take that and we can write that brightness. We got to write it still to the LED. We got to say, hey, take this brightness in, this knob turn, which is 0 to 1023, and that's mapped to the 0 to 255, that brightness, and transfer it to the LED. So we have to write to that LED. And that involves an analog write, like we did before. And we say LED pin. And we say we want to, instead of we would write analog write high or low, we're actually going to analog write the brightness on or off. We're going to actually analog 0 to 255. And so we can say, hey, brightness. And then we can close this. And that's essentially all the code. That's all the code we need. And we can end up uploading this to our little board. So again, very simple. We're just converting here the knob range to the PWM brightness range. Oh, my camera went out. But and then we are just writing this sensor data, taking that sensor data in, and then storing that in brightness after it's been mapped, and then telling the LED, hey, turn yourself on relative to brightness. All right, and so we're going to jump out of here, upload to the board, and we'll show you what happens. All right, so we've got our board, and I am going to plug this in. I'm going to turn the knob a direction all the way, one direction, this knob, and then I'm going to plug in the board, and I'm going to upload it. So I'll just go ahead and do that quick. I'll replug the board back in, make sure I'm selected on the COM, and say upload. So we got that sketch uploaded. When I move this now, you'll see that we have the LED super bright or not super bright, all relative to the mapping of that potentiometer. So I'll end up trying to show this here. There's our little circuit. I can turn that knob, and you should be able to follow along and do this too. Pretty cool stuff. So I'm going to show you something quick here. If we were actually to change this number to like 125, so currently it's real bright. It is super bright when we turn it all the way up. And now I upload this with the 125. It's uploaded. It's only mapping to 125. So, and then staying for the 125. So, and ideally, it should be brighter or dimmer based off of that PWM pulse width modulation level. So now it should be brighter. Yep, see how it can be brighter? So we're just mapping that pulse width modulation of those pulse widths in that square wave. So that's it.